In this video, we're going to take a look at one of the tools in thinking particles. This tool is located under the operators, under the tools category. It's called CollisionMap. CollisionMap is going to be useful for specifying a target object and then having either other objects or particles collide with that object and create a bitmap series showing where those objects have collided. And then those bitmap images, sequences, can be used with things like fragment or matter waves to control where things fragment or particles get emitted. Let's go ahead and take a look. We've got one dynamic set here, matter waves born disabled right now. We're going to use him in a second. We're going to start off with a little more simple example. We're going to create a rule called CollisionMap, and we're going to go ahead and just drop that CollisionMap in there. Now the first thing that we need to specify is the target. Where's this map going to be created? Who's it going to be created on? It's going to be created on this big orange sphere, sphere 01. And then any other objects that we pick are going to be used to calculate the collision on this source object. So we'll go ahead and pick this other sphere here. And this other sphere is animated to move across here like this. Let's go ahead and take a look at the other parameters. We've got a group listing. Group, this will allow us to pick which particles are going to be painting this source object. We've got the select record file. This is where we're going to actually pick and create the bitmap sequence. We'll call this callmap1 and just give it a name. We'll use a JPEG sequence. We want to go ahead and use the active time segment. You can specify just a range if you want. Subsamples is going to be useful for controlling how fine that map is created, adding extra subsamples to get a more accurate collision map. Material ID is useful if your source object has multiple material IDs. If you set this to 0, it's going to go ahead and paint across all the IDs. If you only want to paint on a specific material ID, you can do that here. We're going to go ahead and set it to 0 for now. And also the UV channel, which UV channel on that source object do we want to paint on? We're going to use UV channel 1. If you had a different, maybe a UV map modifier on them and wanted to use that, you could specify that as well. Not UV0, but UV1. Scan depth is used. It's a very interesting setting. It uses this determines the ray length for which the collision is calculated. So anywhere on this surface, anything a distance from 10 units away is going to go ahead and create a white marking on that surface. I should mention the collision map is going to be all black in the beginning, meaning no collision, and anywhere a collision happens it'll end up being white, and that's why you can use it with things like fragment map or matter waves. Next up, we've got the map width and height, and those are just going to determine the dimensions of the bitmaps. Reset map per frame, this is going to be used if you want to only show the collision per frame. Basically, if you want to reset everything, every frame update. If we leave this off, what will happen is anywhere the collision happens, that collision marking is going to stay on all of the subsequent images. If we turn this on, then if that marking happens on one frame and then the object moves away, then that marking is going to go away. It's not going to be visible on the next frame. It only shows where they actually happen at that time. We're going to leave that off. We actually want to see all the collision markings build up over time. Redraw views, if we have this on and we hit record, we will actually see everything moving here in the viewports. That's going to take up some CPU, so we're going to go ahead and turn that off. And viewport render, this is going to be used in conjunction with the master dynamic viewport and render subsampling. Depends which one you want to use for this. We just want to go ahead and use the viewport. That's fine. It's the only one we have set. So here's the record button. This is what we're going to press to actually begin the recording and create that series of bitmaps. We're going to do that in just a sec. Automatic record, this is an interesting one. If you check that and then you're about to render your sequence, once we hit render here, it's actually going to go ahead and automatically call this record function and record all the collision maps first, and then it'll come back and render your file sequence. So a pretty interesting little function there. And then there's the blow up, which is great. Blow up is actually going to have the collision map grow and spread over the surface over time. And this speed value here determines how fast it's going to do that growing. But it's interesting to know this speed is actually, the lower the number, the faster it grows. So if you want it to grow slow, put a larger number in there. We'll see that here in a little bit. Okay, so we've got our source object, this orange sphere. We've got somebody to collide against him, sphere 02. We're pathed. Let's go ahead and just record. I'm going to put you on pause. Oh, nope. It's nice and fast. Okay, and of course we don't see anything appear here. If we want to actually see the results, we're going to need to pick the map that we had just created. And we're going to find that under SimCache call map 1. We're going to use the sequence. It's a JPEG sequence. We'll open that. We're going to show the bitmap, select our object, and apply that map to him. Go ahead and replace the previous map that was on him. We're actually going to hide this sphere right here. Just remember that he moves across this way. And what we'll see, we had Blowup turned on. Smooth. Let's try that again. Let's go ahead and record. You can see with Blowup how it was spreading all over the surface really fast. It's not quite what we wanted yet, but okay, so this is much better. This is showing us that as that sphere moves across, it's going to calculate and kind of smear him all the way across there. If we had had reset map per frame turned on, it would only kind of show the current location of the sphere at each frame. Let's go ahead and record that and we'll see what happens there. So you can see the difference there. It's not leaving the trail and accumulating. Okay, we're going to go ahead and turn that off. Let's actually take a look at Blowup. You saw what happened kind of when Blowup was set to 1. It really covered the surface quickly. We're going to go ahead and set it to 20 and record. And what we'll see this time is that as that collision happens, it's going to spread over the surface very slowly now. So it hits, and you can see it begin to spread as it goes. And it's covering this whole surface. So this is very useful for especially collision maps. I'm sorry, fragment operator. If you use the collision map created in conjunction with the fragment operator, you can spread out certain ways. Especially if you're using particles to collide, it can spread out the collision. Of course, fragment operator now in TP3 has a crack spreading, which we're going to take a look at in the fragment video.